Alright, so for this question, we'll be writing a balanced molecular equation for the reaction between aluminum metal and chlorine. First, of course, we'll need to write down our chemical equation. We have Al, aluminum, plus Cl2, chlorine, yields AlCl3, which is aluminum chloride. First, we'll need to count all the atoms on each side of the equation for each element. So first we have Al equals 1 over here, Cl equaling 2, as we can see. And then on this side of the equation, we have Al equaling 1, and Cl equaling 3, as we can see here. So now what we need to do to balance the equation is we need to get these two to equal each other. Of course, we can see the CL's are off, 2 and 3, but we have 1 of each here, so that's good. But the quickest way to do this equation would be, we know 3 times 2 is 6. So what we'll do here to do that is we put a 2 here, which will make this also times 2 equals 2. So we have 2 Al Cl 3, and then come over here, we need 2 Al and 6 Cl, so we'll do 2 times 3 equals 6. Put the 3 here. So now we have 6 Cl over here and 6 Cl over here, and then to balance the aluminum, you just times 2 equals 2. Put that here, and we have a balanced chemical equation for the reaction between aluminum metal and chloride, or chlorine rather. So, question number 2. What type of reaction is this? In the instance of Al plus Cl2 yielding AlCl3. So, the best way to figure this out is to look at your types of reactions. Here we have an example of synthesis reaction. We can see that Al, aluminum, is combining with chlorine to form AlCl3. This is A, making it a synthesis or combination reaction. Alright, so for number 3, identifying the oxidation numbers for each species in the reaction of Al plus Cl2 yielding AlCl3. We will need the periodic table and some oxidation rules. One of the most important concepts is that all oxidation numbers must add up to 0 in a neutral compound. First, we'll find chlorine on the periodic table ending up in group 17, or 7A, having an oxidation number of -1, giving an oxidation number of -1. We also know that aluminum has 3 valence electrons that can be easily, well, relatively easily removed, giving aluminum plus 3 charge. Sorry for the blur, but we now have Al with an oxidation number of plus 3, and Cl with an oxidation number of -1 and 3. Oxidation numbers adding to 0 in this compound. When looking at this oxidation reduction or redox reaction, taking place as a synthesis reaction, looking closer into what species is being reduced and which species is being oxidized, we can find that Cl2 is the oxidizing agent, experiencing the reduction, seen as 6 Cl, charge of 0, plus 6 electron, yielding 6 Cl, charge -1, and it's seen being reduced. And when you're looking at which species is being oxidized, we'll see that Al is the reducing agent, or the one receiving the oxidation. Seen through 2 Al charge minus 6, yielding 2 Al3 oxidation, being oxidized. I'd like to note that this is probably better easily understood if we insert the balanced chemical equation, so you can understand that. The oxidation numbers and the charges. And states. This should clear it up if it wasn't clear before. This should be 3. It should be 1. There. And this explains this, or this explains this rather. So, for question number 6, if 15 grams of each reactant is present, what is the mass of the product produced? Now what I did is I just wrote down, 15 grams of Cl2 and 15 grams of aluminum. We're looking for our products. And I wrote down the atomic weights. So aluminum atomic weight is 26.98, and Cl2 is 70.90. So what we're going to want to do is we want to write down how many grams, 15 grams Cl2 over 1 times 1 mole Cl2 over 70.90 grams Cl2, which is its weight. And we want to do it because there's 2 moles of the product. It's a times, not a point, just so you know. Divided by 3 moles of the Cl2, because that's what we're using here. And we have 133.34 grams of AlCl3. And then we want to divide, oh my goodness, you couldn't see that, I'm sorry. It's hard to write in video. But we have 133.34 grams of AlCl3. Divide that one last time by 1 moles of AlCl3 to get the final product. 39 point, oops, this is incorrect. To get the final product of equals 18.81 grams of the product. Oop, this is supposed to be a 3, AlCl3. There we are. And I'd just like to note that this number right here, that came from this. The AlCl3 weighs 133.34 grams divided by 1 mole, including the rest of this equation, equals 18.81 grams of the product. So, for number 7, we'll be determining the enthalpy of formation for the product of this equation, or for this reaction rather. and the reaction, of course, being alright, so this is how we would go about finding the enthalpy. Delta H equals M times S times the delta of T. M in this equation being mass of the reactants times heat of the product times the change in temperature. So what we would do is I did a little research and found the relationship between grams of aluminum reactants with chlorine and the amount of kJ of heat produced. And given the information that 12.50 grams of aluminum reacts with chlorine, it makes 346.3 kg, or kJ rather, of heat. So, this is the relationship between the reactants. Heat over the amount of product of aluminum. So, what we want to do is the 2Al from the balanced equation times the weight of the Al. So we go 2 molecules Al times 26.98 grams Al divided by 1 molecule Al times, of course, our relationship over here equals negative 1,495 kJ, as you can see here.